I'm going to do what the Harvard students said. And the bulb doesn't light. And you all already know why it doesn't light. You've got to complete the loop so that current can flow. If current can't flow through the light bulb, then the light bulb is not going to light. So to do that, I need to close all the switches in the loop, which are 1, 5, and 6. You got it right, all but 4 of you. So the answer indeed is 1, 5, and 6 here. What happens when I close this switch here, putting these 2 bulbs, so now I get the second bulb into the circuit, all right? So we have A, it decreases, and C, it remains the same. Okay, ready? You're watching this bulb here. I hope that what you're seeing is that the brightness of this bulb remains constant. So let's see what actually happens. Some of you thought it gets dimmer. Some think it gets brighter. Some think it remains the same. Right? All 3 of those possible answers. So let's go ahead and close this switch now, including this bulb in the circuit. Okay. These 2 bulbs are actually still lit. If you notice here, they are still lit. What's happened now is that by adding this second, you should never do this with 120 volts, by the way. Again, Professor Dwyer was very kind to me, and he didn't power this circuit with 120 volts. Because if I had my hand on 120 volts right now, I wouldn't be talking to you. But what we've done is to put these 2 switches in parallel. These 2 bulbs in parallel. When I did that, the resistance of these 2 bulbs in parallel must always be lower than each of the bulbs that make up the parallel circuit. Because they're adding up the inverses, it turns out when you add resistors in parallel, the net resistance is always lower. Right? So I dropped the resistance here. When I did that, I decreased the total resistance around the whole circuit because I dropped this by a factor of 2. And because I dropped the total resistance, more current can flow through the circuit. All of that current has to flow through bulb 1, bulb X rather, in order to get through the other 2 bulbs. Now that current that's flowing through bulb X here has got to split between these 2 bulbs. And the power is I squared R. And so the power that this bulb is burning is 1/4 of the power of that bulb, and this one's 1/4 of the power of that bulb. Okay? Overall, these are burning half what that one